right, so we're going to go ahead and go over some reaction efficiency questions. So this assignment on here is going to be titled Reaction Efficiency Practice on Canvas. So this is your actual versus theoretical yields. So what we have to do is we have to use stoichiometry to figure out what the theoretical yield of a substance will be, and then figure out how efficient that reaction was based off of what the actual outcome was. So here, I'm trying to make sure this is all on one page for you. Sorry, I've got my phone like rigged up on a cup. So here on this first one, you have a balanced equation. Okay, that's what you always have to start with, no matter what. So if you do not have the equation, that means you have to write it out. So on one, like on the bottom here, like on number 3, you would have to write out this equation first, then balance it, and then complete the question as it's asked. So up here, we'll do an example of that in a minute, but right now for number 1, we have 2 aluminum hydroxide plus 3 calcium chloride yields 2 aluminum chloride and 3 calcium hydroxide. Okay, so we already know that much. So this is telling us that if you began the reaction with 20 grams of calcium chloride, what is the theoretical yield of aluminum chloride in grams? So what that tells you is this is a gram to gram or a mass to mass stoichiometry problem. Okay, so we have mass here and mass here. So we're going to have to go from what was given in the problem to the other reactant or the other product, whatever's given in the question. So in this case, you're trying to figure out the yield of the aluminum chloride. So we're going to start off with the 20 grams of calcium chloride and plug that in here. So we know we're going to have 20 grams of the calcium chloride. Okay. Since this is a mass-to-mass stoichiometry problem, we know we're going to have to convert it into moles, use the mole ratio, and then convert it back into mass. So right here, we're going to convert it into moles, which means that we're going to put the mass of what we started with on bottom. So we're going to have to calculate the mass of calcium chloride, put it here. 1 mole goes on top. Okay. So let's go ahead and add this up. I can't just pause this because it is on my phone, so we're just gonna do it real time. So what do we have here? We have 1 calcium and 2 chlorines, so we're gonna add those up. So if we look on our periodic table, calcium is 40.078 plus the 2 chlorines, and each of those are 35.45. Okay, so you can even see that, but this is how I've got it set up in my calculator. So it's going to tell me that the whole mass of the calcium chloride is going to be 110.978. So I'm going to put 110.98. Okay. So now at this point, grams of calcium chloride have canceled, and we're in moles of calcium chloride, which is in the we're getting there. So moles of calcium chloride has to go on the bottom. We don't know what number yet until we look at the equation. So this is where the mole ratio comes in. You need the ratio of what you're starting with to what you're ending with. So here we know we're starting with calcium chloride. We're going to end in aluminum chloride, so we have to find those 2 up here. So we have 3 moles of calcium chloride here is going to produce 2 moles of aluminum chloride here. So that's the ratio. It's 3 calcium chloride to 2 aluminum chloride. So we're going to write that in. We know that calcium chloride has to go on the bottom because this is how our dimensional analysis works. We've been doing this, all year. So moles of calcium chloride is going to go on bottom. So you're going to have 3 moles of calcium chloride on bottom to 2 moles of aluminum chloride on top. Okay, so now the moles of calcium chloride have canceled. Now we're in moles of aluminum chloride, which is great. It wants to know the mass, so we're gonna have to convert this back into mass. Okay, so similar to what we did on this portion, it's gonna be 1 mole to the mass, but over here it's just gonna be flipped upside down because moles are on top this time, so moles has to come down. So for every 1 mole of aluminum chloride, we're gonna have, I need to figure out our mass here. Okay, so here, I had originally read this incorrectly. It's 3 of these. Okay, so I'm just gonna adjust that here. These are 3. We got that from our equation, so that 3 was there. Just was moving too fast. So when you add up the mass of aluminum chloride, that's 1 aluminum plus 3 chlorines, is gonna give you 133.33 grams of aluminum chloride. So now you're going to solve this just like you have been all year with your dimensional analysis, okay? So you're going to multiply everything across the top, multiply everything across the bottom, and then divide the two. So you can put this in your calculator all at one time, but you have to do it the right way. So you're going to start off with parentheses and multiply everything across the top, close that parentheses, then hit divide, make a new set of parentheses for the bottom. So 110.98 times 3 times 1, close your parentheses again. So that gives you 16.02 grams of aluminum chloride being produced. Okay, so what this number is telling you is that this is the theoretical yield. So if you started, in theory, if we started with 20 grams of calcium chloride, you should produce 16.02 grams of aluminum chloride. That's in a perfect reaction with 100% efficiency. That is not usually what happens in real life. We usually have some sort of loss of efficiency somewhere. So in a perfect reaction, the theoretical yield would be this, but we know that that's not what really happened. And so part B gives you that scenario. It says you actually produce 13.55 grams of aluminum chloride. What's the percent yield? So percent yield, this equation was in your notes, but the percent yield for that is going to be the actual value over the theoretical value times 100 to give you your percent yield. So you'll use this equation every time to find the reaction efficiency. So in this case, we have the actual is the 13.55 divided by the theoretical, which is 16.02. We're going to times by 100, and that's going to give us a percentage. So this is going to be 84.58% efficient. Okay, so this reaction turned out to be 84.58% efficient. So this is useful in lab situations especially, and this is used on, let me find that, the percent yield of a chemical reaction lab. Okay, so the same thing that we just talked about, you'll have to write and balance your equation based off of what's here in this highlighted sentence there. But then on the back side, this is telling you what's the percent yield of the reaction, right? So you're going to say that we actually produced 0.535 grams of sodium chloride in this reaction. So in class, students actually did this reaction and we actually got these results, okay? So what you have to do is figure out the theoretical yield, okay? So that's number 1. So you're going to figure out the theoretical yield of the sodium chloride. Okay, we know that we're going to start with 1.012 grams of the sodium bicarbonate. Okay, so we're going to take this, and that will be in the first portion of your dimensional analysis box. And we're gonna convert it as a mass-to-mass stoichiometry problem into sodium chloride, okay? So you'll do exactly the same thing that you did here. Okay, the only thing you would change is that you start here with the 1.012 grams of sodium bicarbonate. We'll go here. You're gonna do the same thing. You're gonna get your mole ratios from your equation. That's gonna be on the front part of this lab. And then you're going to convert it into sodium chloride. Then you compare it to the actual. Okay, so that's going to be 1 and 2. You're going to do the percent yield for that. And then 3 is another stoichiometry problem. This time we're just starting with the sodium bicarbonate and converting it into hydrochloric acid instead. So 1 and 3 are very similar problems. So if we go back to this page, like on number 3, and again, like all these answers are across the bottom, so you can just kind of cross them off as you go. So not necessarily in order, but it kind of gives you an idea if you're working in the right direction or not. Also, don't forget that the keys are also posted online. So every day, like on this day, whatever day we did reaction efficiency, the next day on Canvas, if you click on that in the agenda, there's a link to the key with all the problems worked out. so you can see them and see if you have any problems. You can kind of see where you might have gone wrong. So on number 3, this is giving you your reaction. These are skills that we learned last semester, so hopefully you're good here. But you're going to be writing out the whole equation and balancing it, okay? So here we have, during a single replacement reaction, beryllium reacts with hydrochloric acid. Okay, so we're gonna have beryllium reacts with hydrochloric acid to form, which is our arrow, beryllium chloride and hydrogen gas. Beryllium chloride is going to be BeCl2, and if you remember, it's probably been a little while. Let's see, let me get this back. Beryllium is in group 2. Okay, so you can see that. So beryllium's in group 2, which means it has a charge of +2, and then chlorine is in group 17, which means it has a charge of -1. So when we crisscross those charges, this was a +2, this was a -1. The 1 would come down with the beryllium. We don't write 1s. The 2 from the beryllium would come down here with the chlorine. Okay, plus the hydrogen gas. So anytime hydrogen is by itself, it is an H2 because it's one of those 7 diatomic molecules. So then we would need to go through and balance this. Looks like this one's an easy one to balance. So the berylliums are already even. The chlorines are not, okay? So if there's 2 chlorines on this side, there needs to be 2 over here. So we're gonna put a 2 in front of that so that we have 2 chlorines. Now we have 2 H's and we already had 2 on that side. So this is balanced now. So it's the same idea. Okay, so you're just taking this step by step. You know, this one's gonna have you figure out the % yield again. This one tells you though, it tells you your theoretical yield was 10.7 grams and the actual was 4.5. So you're just plugging that in. And there you go.